But again, math does have a lot of vocabulary in it, which is important. All right, so now we have all this. Here's another equation. Okay? So here we have 2x plus 1 equal to 2. Here's another. Did I press record? Yes, I did. Good. So here's another equation. Notice here the domain for the variable is all real numbers. In other words, I could replace x with anything, and both sides of the equation are going to hold. Right? I could do 2 times any number and add 1 to it. I'll get another number. I'll get something that makes sense. Right side also exists for any x. So in other words, the domain for this equation is all real numbers. Okay, well, let's see what happens if we start putting numbers in for x. So let's do that, and we're going to see what happens, okay? So if I replace x with 1, right, what's going to happen? Well, we get 2 times 1 plus 1, right, on the left side, and that is actually equal to 3. So in this case, right, the equation would be 3 equals 2. So again, if we replace x with 1, our equation becomes this. Well, is this a true statement? Well, no. So because this is not true, we get an equation that's false. So for this x, we get a false statement. Okay, what about if x is 0? In that case, we would have 2 times 0 plus 1. Well, that's equal to 1, right? So in that case, the equation would be 1 equals 2. But that's also false. 1 is not equal to 2. Okay, we could keep doing this, for many integers if we want. We'd be here for a while. But what if I replace x by a half? Well, in that case, something really cool happens. 2 times a half plus 1, right? Well, just by basic arithmetic, the denominator and 2 cancel. You get 1 plus 1, which is 2. Well, guess what? 2 equals 2. That's what the equation becomes. Well, anything is equal to itself, so our equation is now true. So what am I getting at? There's an x value, namely a half, that we can replace x with. Excuse me, let me say it again. There's a number we can replace x with in the equation that gives us a true statement, that makes the equation true. Well, that number is given a special name. We call it a solution. So a solution is a number you can replace the variable with and get a true statement. Or more accurately, or more precisely, this is what a solution is to an equation. It's any value of the variable that makes the equation true when you plug the number in. That's what a solution is. So we found a solution to that equation. And when you're looking for the solutions, when you're finding them, that process is called solving the equation. So we have a solution. I know some people call a solution a root of the equation. I just like to call it solution, but just letting you know. Finding these solutions is what we call solving the equation. Now, this is something the book uses, this terminology. I don't remember if Lumen Learning uses it, but it wouldn't hurt to see it anyway. The collection of all solutions, that's for an equation. That's called the solution set. The solution set. Again, that's just a collection of all solutions for that equation. That's all. If there are no solutions, then the set is empty. The empty set, meaning it has nothing in it. That can happen. We saw, the equation 1 equals 2, right? That was the first equation we saw today, right? But that's false. That's always false. So that solution set would be empty. Okay, so that's just some vocabulary. Okay, so we know what an equation is, right? We know what a solution to an equation is. What it means to be a solution to an equation. We know what it means to solve one. But how do we actually solve an equation? What can we do? I mean, for the equation we did on a previous slide, we basically just guessed, right? But guessing's really not the best way to solve an equation. Basically with guessing, you're kind of shooting in the dark, so to say. You don't want to do that. But there is a process you can do. Namely, you can manipulate an equation and obtain one that's much easier to deal with. So what we can do is we can perform operations on an equation and get one that's easier to deal with. And what can we do? What operations? Well, that's what these statements are saying. No, you could simplify either side by just using basic arithmetic. You could do that. You can add or subtract the same expression to both sides. This doesn't really come up too much in the class. It has to have the same domain as the original equation, mostly because when you add and subtract something, you want the domain to be the same, so you're not removing or adding solutions to the original equation. The whole point is you want to manipulate the equation so that you don't add or remove any solutions. You don't change the solution set. That's why you can perform these manipulations. So you can add or subtract the same thing to both sides. You can multiply or divide by the same non-zero number, or you could also interchange both sides. Again, you can't do whatever you want. You can only do these manipulations because you don't want to change the solution set. The whole point is you want to obtain an equation that's much easier to deal with, one you can solve more easily. And when you solve that equation, you get the solution set to the original one. That's the whole point of this. Okay. All right. So this is what we can do. Let me just say this also. When you start with one equation and you manipulate it using any of these manipulations, what you get is said to be equivalent. So in other words, two equations are equivalent if you can obtain one from the other by using any of these operations. Simplifying either side, add or subtracting the same thing, multiply or dividing by the same non-zero number, or interchanging both sides of the equation. So if you can get from one equation to another using any of these operations, even more than one, then the equations are equivalent. Okay. Finally, let's get to what a linear equation is. I mean, what we said so far really applies to any kind of equation. But for now, we're going to look at linear equations. They're actually pretty straightforward. Mostly because a linear equation in one variable looks like this. Okay, let me just pause this, get the recording going again.